Hello students, we are going to see about decision trees. Decision tree algorithm falls under the family of supervised learning algorithms. Unlike other learning algorithms, it can be used for solving regression and classification problems too. The main idea of using decision tree is to create a training model which is used to predict the class of target variables by learning decision rules inferred from training data. A decision tree is an approach that has a root node, branches and leaf nodes. Each internal node represents a test on the attribute. Each branch represents the outcome of a test and each leaf node represents a class label. The topmost node is the root node of the tree. It builds classification or regression models in the form of a tree structure. It breaks down a data set into smaller and smaller subsets while at the same time a decision tree is developed correspondingly. The final output will be a tree with decision nodes and leaf nodes. A decision node has two or more branches. Leaf node denotes a classification or decision. The topmost decision node in a tree is called root node. Both categorical and numerical data can be handled by the decision tree. Every object has a number of independent and dependent attributes. In order to classify an object, the attribute value is used at each node starting from the root node to determine the branch taken. The path found by testing at each node leads to a leaf node, which is the class the object belongs to. Now, we will see the basic algorithm. Consider a training data set S. Discretize all continuous valued attributes and the root node should contain S initially. If all the objects in the root node falls under the same class, then the iteration is stopped. Split the next leaf node by selecting an attribute A from among the independent attribute that best divides or splits the objects in the node with subsets and create a decision tree node. Split the node according to the values of A. Stop if any of the following condition is met, otherwise continue from step 3. The criteria for stopping is data in each subset belongs to a single class or there are no remaining attributes on which the sample may be further divided. A decision tree has the following benefits. It does not require any domain knowledge, easy to comprehend and simple and fast. Now, we will see about building a decision tree. A decision tree consists of a root node, a number of internal nodes and a number of leaf nodes. Building the tree starts with the root node and then splitting the data into two or more child nodes. Splitting continues at lower level nodes until the process is complete. As already noted, each internal node of the tree represents an attribute and each leaf node represents a class label. Decision tree algorithm pseudocode has the following steps. Step 1. Place the best attribute in the data set at the root of the tree. Step 2. Split the training set into subsets. Subsets should be in such a way that each subset contains data with the same value for an attribute. Step 3. Repeat steps 1 and 2 on each subset until you find a leaf nodes in all the branches of the tree. There are few assumptions assumed while creating a decision tree. It includes, in the beginning, the whole training data set is considered as the root. Next, feature values are preferred to be categorical. If the values are continuous, then they are discretized prior to building the model. Next, records are distributed recursively on the basis of attribute values. And lastly, order to place attributes as root or internal node of the tree is done by using some statistical approach. Decision tree follows sum of product representation known as SOP. The picture shows how we can predict the computer usage daily by traversing from the root node to the leaf node. The sum of product SOP is also known as disjunctive normal form. For a class, every branch from the root to a leaf node having the same class forms a product. Different branches ending in that class form a sum. The primary challenge in the decision tree implementation is to identify which attribute is to be considered as the root node at each level. We have different attributes selection measures to identify the root node at each level. The popular attribute selection measures are information gain and Gini index. For a data set consisting of n attributes, it is very hard to decide which attribute to place at the root or at different levels of the tree as internal nodes. If we select root node by random approach, it may give us bad results with low accuracy. For solving this attribute selection problem, researchers suggested some criteria like information gain and Gini index. These criteria will calculate the values for every attribute and the values get sorted and attributes are placed in the tree by following the order, that is, the attribute with a high value is placed at the root. Attributes are assumed to be continuous for Gini index, while it is assumed to be categorical for information gain. Now, we will see in detail about information gain. With the use of information gain, now we will see about information gain in detail. With the use of information gain, we try to estimate the information contained by each attribute. Entropy is used to measure the uncertainty of a random variable x. For a binary classification with two classes, namely positive and negative, if all samples are positive or all are negative, then entropy will be 0, that is low. If half of the records are of positive class and half are of negative class, then entropy will be 1, that is high. By calculating entropy measure, we can calculate the information gain. Information gain calculates the expected reduction in entropy due to sorting of the attribute. To get a better understanding of calculating information gain and entropy, we will try to implement it on a training data. Consider, for example, a decision tree by using information gain as a criterion in the table. In the table, as per information gain criterion, we have 5 columns, out of which 4 columns have continuous data and the 5th column has class labels. Column A, B, C and D attributes can be considered as predictors and column E, that is class label, can be considered as a target variable. To construct a decision tree from this data, we have to convert continuous data into categorical data. We have chosen some random values to categorize each attribute. For attribute A, greater than or equal to 5 and less than 5. For attribute B, greater than or equal to 3.0 and less than 3.0. For attribute C, greater than or equal to 4.2 and less than 4.2. For attribute D, greater than or equal to 1.4 and less than 1.4. There are two steps for calculating information gain for each attribute. Step 1, the entropy of target is calculated. Step 2, entropy for each attribute, namely A, B, C and D needs to be calculated. This entropy is subtracted from the entropy of target. The result is nothing but information gain. In this example, to calculate the entropy of target, we have equal number of records, 8 records with negative class and positive class. So, we can directly estimate the entropy of target as 1. Calculating entropy using a formula. Entropy using the frequency table of one attribute is given by the formula entropy of S is equal to summation over I equal to 1 to C minus Pi into log Pi to the base 2. For variable E, we have equal weightage 8, 8. So, entropy of 8, 8 is equal to minus 1 into probability of positive into log of positive value to the base 2 plus probability of negative into log of probability of negative to the base 2, which is equal to minus 1 into 8 by 16 into log of 8 by 16 to the base 2 plus 8 by 16 into log of 8 by 16 to the base 2, which is equal to 1. Now, for calculating the information gain for variable A. Variable A has value greater than or equal to 5 for 12 records out of 16 and 4 records with value less than 5. Now, to calculate the information gain for variable A greater than or equal to 5 and class equal to positive, the probability is 5 by 12. For variable A greater than or equal to 5 and class equal to negative, the probability is 7 by 12. Therefore, entropy 5, 7 is equal to minus 1 into 5 by 12 into log of 5 by 12 to the base 2 plus 7 by 12 into log of 7 by 12 to the base 2, which is equal to 0.9799. For variable A less than 5 and class equal to positive, the probability is 3 by 4. For variable A less than 5 and class equal to negative, the probability is 1 by 4. Therefore, entropy 3, 1 is equal to minus 1 into 3 by 4 into log of 3 by 4 to the base 2 plus 1 by 4 into log of 1 by 4 to the base 2, which is equal to 0.81128. Entropy using the frequency table of two attributes is given by entropy of T, x is equal to summation over C element of x P of C into E of C, where P is the probability and E is the entropy. Now, for variable A, entropy of target, A will be equal to probability greater than or equal to 5 into entropy of 5, 7 plus probability less than 5 into entropy 3, 1, which is nothing but 12 by 16 into 0.9799 plus 4 by 16 into 0.81128, which is equal to 0.937745. Information gain is given by the formula gain of T, x is equal to entropy of T minus entropy of T, x. Now, for variable A, information gain G is equal to entropy of target minus entropy of target, A, which is equal to 1 minus 0.93, which is equal to 0.06. Now, calculating the information gain for the next attribute variable B. Variable B has value greater than or equal to 3 for 12 records out of 16 and 4 records with value less than 3. So, for variable B greater than or equal to 3 and class equal to positive, the probability is 8 by 12. For variable B greater than or equal to 3 and class equal to negative, the probability is 4 by 12. Therefore, entropy 8, 4 is equal to minus 1 into 8 by 12 into log 8 by 12 to the base 2 plus 4 by 12 into log 4 by 12 to the base 2, which is equal to 0.39. For variable B less than 3 and class equal to positive, the probability is 0 by 4. For variable B less than 3 and class equal to negative, the probability is 4 by 4. Therefore, the entropy 0, 4 is equal to minus 1 into 0 by 4 into log 0 by 4 to the base 2 plus 4 by 4 into log 4 by 4 to the base 2, which is equal to 0. Therefore, entropy target B is equal to probability greater than or equal to 3 into entropy 8, 4 plus probability less than 3 into entropy 0, 4, which is equal to 12 by 16 into 0.39 plus 4 by 16 into 0, which is equal to 0.29. Now, information gain is equal to entropy of target minus entropy of target B, which is equal to 1 minus 0.29 equal to 0.707. Similarly, the information gain is calculated for attributes C and D. From these calculations, a decision tree can be built. According to their values, the attributes should be placed on the tree. An attribute with better value should be placed as the root node, and a branch with entropy more than 0 needs further splitting. A branch with entropy 0 should be converted to a leaf node. Now, we will see in detail about the next index called the Gini index. Gini index is used to measure how often a randomly chosen element would be identified incorrectly. It means an attribute with lower Gini index should be considered. Given the example to construct a decision tree by using Gini index as a criterion for the frequency table given. In the table, as per Gini index criterion, we have 5 columns, out of which 4 columns have continuous data and 5th column has class labels. Criterion A, B, C and D attributes can be considered as predictors, and E column class label can be considered as a target variable. For constructing a decision tree from this data, we have to convert continuous data into categorical data. We have chosen some random values to categorize each attribute. For attribute A, greater than or equal to 5 and less than 5. For attribute B, greater than or equal to 3.0 and less than 3.0. For category C, greater than or equal to 4.2 and less than 4.2. For attribute D, greater than or equal to 1.4 and less than 1.4. From this, the Gini index is given by 1 minus summation over j probability of j square. That is the formula for Gini index. Gini index for variable A can be calculated for the table as below. Variable A has value greater than or equal to 5 for 12 records out of 16 and 4 records with value less than 5. For variable A greater than or equal to 5 and class equal to positive, the probability is 5 by 12. For variable A greater than or equal to 5 and class equal to negative, the probability is 7 by 12. Therefore, Gini index 5, 7 is equal to 1 minus 5 by 12 square plus 7 by 12 square, which is equal to 0.48. For variable A less than 5 and class equal to positive, the probability is 3 by 4. For variable A less than 5 and class equal to negative, the probability is 1 by 4. Therefore, Gini index 3, 1 is equal to 1 minus 3 by 4 square plus 1 by 4 square, which is equal to 0.375. By adding weight and sum each of the Gini indexes, Gini of target, A will be equal to 12 by 16 into the calculated value 0.486 plus 4 by 16 into the calculated value 0.375, which is equal to 0.45. Now, to calculate the Gini index for the next attribute B. Variable B has value greater than or equal to 3 for 12 records out of 16 and 4 records with value less than 3. For variable greater than or equal to 3 and class equal to positive, the probability is 8 by 12. For variable B greater than or equal to 3 and class equal to negative, the probability is 4 by 12. Therefore, Gini index 8, 4 is equal to 1 minus 8 by 12 square plus 4 by 12 square, which is equal to 0.44. For variable B less than 3 and class equal to positive, the probability is 0 by 4. For variable B less than 3 and class equal to negative, the probability is 4 by 4. Therefore, Gini index 0, 4 is equal to 1 minus 0 by 4 square plus 4 by 4 square, which is equal to 0. Now, the Gini index of target, B will be equal to 12 by 16 into the calculated value 0.44 plus 4 by 16 into the calculated value 0, which is equal to 0.33. The Gini index is calculated similarly for other attributes C and D also. This way, the attributes can be used to fit the root value in the tree. The only problem with decision trees are overfitting. While building a decision tree model, we will face a problem of overfitting. The model has an issue of overfitting when the algorithm continues to go deeper and deeper to reduce the training set error, but results with an increased test set error. That is, accuracy of prediction goes down. It generally happens due to outliers and irregularities in the data. Two approaches can be used to avoid overfitting. They are pre-pruning and post-pruning. Pre-pruning. In pre-pruning, the tree construction is stopped little earlier. It stops splitting a node if its goodness measure is below a threshold value, but it is very difficult to choose a stopping point. Post-pruning. In post-pruning, it constructs a deeper and deeper tree in order to build a complete tree. If there is a overfitting problem, then pruning is done as a post-pruning step. The effect of pruning will be checked by using cross-validation data set. By using this cross-validation data, it tests whether expanding a node will make an improvement or not. If there is an improvement, then we will continue by expanding that node. But if there is a reduction, it should not be expanded. That is, that node should not be converted to a leaf node. Now, we will see the advantages and disadvantages of decision tree. Firstly, advantages. First one, decision trees are easy to explain. Next, it follows the same approach as humans while making decisions. Next, interpretations of a complex decision is easy with decision tree model due to simplified visualizations. Even a naive person can understand logic. Lastly, the number of hyperparameters to be tuned is almost null in decision trees. Coming to disadvantages, the probability of overfitting in the decision tree is high. Next, compared to other learning algorithms, it gives low prediction accuracy for a data set. Next one, information gain is a decision tree gives a biased response for attributes with greater number of categories. And lastly, calculations become complex when there is more number of class labels. To conclude, decision tree is a supervised learning method which is used for classification and regression. It is used for both numerical as well as categorical data. It has a root node, branches and leaf nodes. Leaf nodes determine the class of an attribute. It is calculated by Gini index and information gain. Decision trees have human-like logic. The only disadvantage is overfitting, which can be overcome by pre-pruning and post-pruning. Thank you, students.